Hello, young scientists. Welcome back. In today's class, we will understand how electricity flows through the electric circuit and how measuring instruments help us to understand it. We will also learn about the Ohm's law and how resistance combine to form series and parallel circuits. So let us begin with the first one. Let us try to understand something regarding the electric circuits. Children, what is an electric circuit? Electric circuit is simply a closed path in which electric current starts flowing. Okay? A closed path in which electric current flows is called as simply electric circuit. And this electric circuit consists of many electrical elements like bulb, fuse, switches, electric wires, and so many. And these elements have their own functions. For example, if you consider an electric wire, this will connect one electrical element with the other electrical element. So this is the function of an electric wire. Similarly, if you consider a switch is having two functions. One is on and the other is off. Whenever the switch is kept on, the circuit is kept said to be closed circuit. In the closed circuit, the electric current starts flowing. But whenever the switch is kept off, then the circuit is said to be an open circuit. In an open circuit, no flow of electricity takes place. Okay, so open circuit and closed circuit. Open circuit, when the switch is off, no flow of current. Closed circuit is when the switch is on and the flow of current takes place in that circuit. Okay, now let us also have look into the symbols of these few electrical elements. So here we go with that. First of all, so these are the few symbols of your electric elements. Let us discuss them in detail. The first one indicates the symbol for a electric bulb. So we know bulb in electricity, generally we connect few small bulbs and all. So whenever you draw a circuit, then whenever you would like to say that a bulb is connected in the circuit, then we will be using this symbol for bulb. I said that the switch may be closed and the switch may be open. So whenever the switch is closed, the symbol something like this, and whenever the symbol open, it is connected as sun. Okay. So plug key when it is closed and plug key when it is open. So this is all about your switch. So switch is open, switch is closed. Open switch, closed switch. This is all about your plug key. Almost both means the same. Plug key, open plug key, and this is your closed plug key. This is on and off switch, and this is closed and open plug key. This is the symbol for resistor. This can also be called as a resistance because it offers resistance. And here is the symbol for rheostat. So last class I have already shown you how the rheostat looks like. The other name for rheostat is a variable resistor because in this resistor it gives a fixed value. Okay, whereas in the variable resistor the resistance can be changed to different values because it has some movable circuit over there. And this is the symbol for conductors. So here this one is a conductor, here also it is a conductor. This is a connected conductor. When the conductors are connected, so this is the symbol for that, connected conductor. Whereas these two indicates the unconnected, no joining, unconnected conductors. Here it is some space you can see, and here also it is an open. Okay, this is some loop-like structure you can see. So these two symbols are used for unconnected conductors, and this symbol is used for connected conductors. And this is a symbol for ammeter, and here is the symbol for voltmeter. Whether it is an ammeter or a voltmeter, we have two terminals will be there. One is the positive terminal, the other is your negative terminal. So let us try to discuss regarding the ammeter and voltmeter in detail. Okay. So what is an ammeter? So ammeter, ammeter or ampere is the unit for electric current. So ammeter is an instrument used to measure the amount of electric current passing through a circuit. Whereas voltmeter is an instrument which is used to measure the amount of potential difference applied across a circuit. Okay. So I hope the symbols are clear. Okay. So now we shall move to the next concept regarding the common measuring instruments. So just now we have discussed some measuring instruments, measuring elements we have considered recently, that is ammeter and voltmeter. The function of ammeter is to measure the amount of current flowing across the circuit, whereas the voltmeter tells us about the amount of potential difference applied across a circuit. Okay, so the common measuring instruments here, let us discuss. One is all about your ammeter. Next, regarding voltmeter, and also multi-ammeter. Multi-ammeter or multimeter is also called as VOM. The meaning of VOM is volt-ohm multi-ammeter. Volt-ohm ammeter. Okay. So anyhow, first of all, look at the ammeter. So this is how an ammeter looks like. So if you consider this ammeter, symbol A indicates your ammeter. It here has some readings over there. So 0 amperes, 0.6 amperes, 1.2 amperes, 1.82. So some readings are given. Okay. So this you can even observe a pointer on this Okay, this pointer shows the amount of electric current passing through the circuit whenever this ammeter is connected in a circuit. Let us also look into the circuit diagram for this. Okay, so it has two terminals. One is a negative terminal, the other is a positive terminal. Generally, red color indicates your positive terminal. Here it is indicated. Red color indicates your positive terminal and black color indicates your negative terminal. Okay, so how, as I already told you that the symbol for ammeter is something like this, plus and minus. Okay, let us look into the circuit diagram of this ammeter. I'll use cell for this because we need to generate current. Okay, so first of all, instead of like this, some elements can be connected. So now I have replaced it with some electric cell. Okay, so I told you cell means it may produce a 1.5 volts and all general household purposes, whatever we'll be using. So whenever the plug key is closed, current starts flowing in the circuit, something like this. The current I starts flowing in the circuit. The amount of current that is flowing is measured by this ammeter connected across it. Okay, whenever some amount of current is passing through that, it indicates the reading which shows the amount of current flowing through the circuit. So as a result, the bulb may glow. Okay, the bulb will glow. Well, and if you observe this, the current after passing through the ammeter again passes through the bulb. So if the same current supposed to be passing both through the ammeter and through the bulb, same amount of current is passing, then we say that the elements are connected in series. So these elements in this particular circuit are connected in series. Okay. So how much current is supplied to the bulb can be given by the reading that is observed in the ammeter. So always remember children, ammeter is always connected in series to the circuit elements whenever we connect it in a circuit. Okay. So now let us try to understand something regarding the voltmeter. This is how a voltmeter looks like. Earlier, ammeter is indicated with the letter A, which measures the current, whereas voltmeter is represented with the letter V, which indicate the potential difference across two terminals. Okay. Well, here also it has two terminals. One is positive terminal. Generally, red is marked as positive terminal. Black indicates your negative terminal. This voltmeter in circuits are always connected in parallel. Okay, so let us also look into the electric circuit diagram for this voltmeter. Here we go. So this is the circuit diagram in which we are using voltmeter. As I said that voltmeter indicates the potential difference across the two terminals. Okay. Here, whenever the plug key is closed from the cell, the electric current starts flowing. Okay. In this direction. Conventionally, it is taken from the positive terminal. So, the electric current I starts flowing through this circuit. So, in this bulb, I amount of current flows and the same amount of current passes across it. Okay. So, this is a series combination. But here, this current will be divided into two parts. One is going through the voltmeter. The remaining amount of current is passing across the bulb. Okay. So, here the current is divided. The amount I is equals to some I1 and I2. So, in the voltmeter and the bulb, two different currents are being passing. But what makes the common means this terminal here, the other positive terminal here. Even for the bulb as well as the voltmeter, the same potential difference is applied across its end. So, same amount of potential difference is applied across the ends. But current will be different. Okay. So, we can say that if you consider two bulbs, so let me name those bulbs as some L1 and L2. Okay. So, these are two different bulbs and we have connected the potential voltmeter across the second bulb. Potentiometer, the voltmeter is connected across the second bulb, say L2. And this voltmeter, whenever the circuit is closed, this voltmeter gives the reading of potential difference across this bulb L2. Only bulb L2, not regarding the bulb L1. This is how voltmeter is connected in the circuits. So, which measures the potential difference. Okay. And remember the children, voltmeter is always connected parallel to the circuit. Parallel combination. Voltmeter is connected in parallel combination, whereas ammeter is always connected in series combination. In the parallel combination, the current will be different even though the potential difference remains constant. Whereas in the series combination, same current flows across the circuit. Okay. So now moving to the one more circuital element that we'll be using in general is a multi-ammeter. It is also called as VOM, meaning volt ohm ammeter. So this has, the name itself indicates that multi-ammeter. So it has multi-functions. It can be used to measure both the current as well as the potential difference accordingly. Okay. And for the higher values as well as the lower values, milliammeters and ammeters can also be measured. So larger values and minimum values can also be measured. So it has its multiple functions. Hence, it is called as a multi-ammeter. Can be used for measuring both the current as well as the potential difference across the circuits.